Hello, this is Emilio, and I'm here to demonstrate my project 4, or aka a 2-bit ripple carry adder. And here it is. So we have my battery hooked up to my voltage regulator, breadboard hooked across all the way. We have my various chips. We have my toggle dip switch with the resistor. We have my AND gate in the first one, my XOR gate in the middle, and my OR gate right here, and then my LCD display. So what should happen here is we have on my first two switches, we have A1 on the left for the first switch, A0, A0 or A0 for the second switch, and then we have B1 at 7, and we have B0 at 8. And so what should happen is, according to this thing, is when we add them up, A1 will add with B1, A0 will add with B0, and depending on the situation, we'll get a sum in the 0 position from B0 and A0. We'll get a sum in the first position from A1 and B1. And what should happen is if A1 and B1 have a carry, we'll have a carry right here. And so I will display these three things as well as all my A1s, A0s, and B1s and B0s. So here's how it works. So for the first case, it says to add 0, 1, and plus 0, 0. So if we do that, have 0, and then we'll flick number 2 as 1. So let me do that. See. So now we have 0, 1. And then in this case, or for B1 and B0, we have 0, 0 as it wanted. So over here it displays what it's saying is this is saying 0, 1. And right here is 0, 0. These two displays, LED displays. And then what over here says, this is my S1, or this is my S0. Here, let me see. This is my S0, this is my S1, and this is my carry 2. So right now it's saying 1 plus 0 is 1, and it checks out. So yeah, that one works. Let's go to my second case, 0, 1 plus 0, 1. So we'll leave this one here, and we'll turn this to 0, 1. So let me do that. Let's see with my finger. Let me see, there it goes. So now, oops. Okay, my bad. So what we have now is 0, 1 plus 0, 1. And so this is being displayed as, over here we have 0, 1 adding to 0, 1. And so what we should get is 2. And so this is my carry 2, this is my S1, and this is my S0. So what this is saying is that 1 plus 1 is 2. And in binary, what that means is when you add 1 and 1, you get a 0 on the first position, and you'll get a carry of 1 to this position. And so it works. 1 plus 1 is 2. 0 here, no carry 2. And so now we have this third case. 1 plus 1, or 3 plus 1, which should be 4. So let's do it now. So we'll make this one 1 and 1. So now as we can see, we have 1, 3, so 1 and then plus 2 to the power of 1. So 2 to the power of 0 is 1, 2 to the power of 1 is 1. 2 to the power of 1 is 2, 2 plus 1 is 3. So now we have 3 plus 1, and that should be 4. So this is my S1 position, this is my S0 position, this is my sum 0 position, this is my sum 1 position, and this is my carry 2. So what should have happened is when we added those, the 1's position should have got to 0 and carried 1 over here to this one. And then what should happen is that 1, and then this 1 over here should have went to 0 and carried another 1 to this position, and that's what happens. And what this represents is 2 to 0, 0, but we have no value, to the 1, which is 2, but we have nothing. So then we have 2 to the 2, which is 4, so it works out. 3 plus 1 is 4. Now the last one. 3 plus 3, and we should get 6. So when I flick this one, let me see, let me do this. Flick this one. So now we have 3 plus 3, and we should get 6. So what happens is the sums in the ones, or in the zeros position, go to 0 and carry. Then we have, what we have is a 1, 1, 1. And so what happens is there should still be 1 left over in here and a carry. And that's what happens because we have a light on, so that means there's still 1 in here. And we have a carry, so that means there's a green light here as well. This represents, so what we have total overall is 2 to the 0, but there's no value. So 0, 2 to the 1, so there's 2. And then 2 to the 2, which is 4, so 4 plus 2 is 6. So they're saying 3 plus 3 is 6, and that is correct. So we have a successful 2-bit ripple carry adder, and that is it.